Good people, welcome so much. This is Prof. Hilary as usual. Today's study is on factors affecting enzymes. Factors affecting enzymes. I'll handle five of them. Five. Temperature, pH, substrate concentration and enzyme concentration, enzyme inhibitors, and coenzymes and cofactors. Five of them. Starting with the first one, temperature. As earlier indicated, is that enzymes are protein in nature. Enzymes are protein in nature. One property of protein is that it's sensitive to changes in temperature. High temperature above optimum, mostly around 40 degrees Celsius, will denature enzymes, will destroy its nature. Denatured enzymes will not catalyze the reaction. Low temperatures below optimum will inactivate the enzymes. Inactive enzymes will not function. As simple as that. 2. pH. pH is the acidity or alkalinity of something. Most enzymes work best at a neutral pH of around 7, while others work best in acidic medium, while others work best in a alkaline medium. Extreme pH, that is too acidic and too alkaline. The extreme pH can also denature the enzymes. The same way high temperature does. For instance, in the stomach, because of hydrochloric acid, that is HCl, some enzymes such as renin and pepsin work best there, while other enzymes such as pancreatic amylase work best in alkaline medium. Number 3, substrate concentration and enzyme concentration. Increase in substrate concentration. Remember I said substrate is food substance. Increase in substrate concentration increases the rate of enzyme activity up to optimum, where further increase in substrate concentration will no longer result in increase in enzyme activity. Why? It reaches a point where the active sites of the enzymes are occupied. Allow me to talk about the active sites. An enzyme has parts known as active sites. Those are the exact places where a substrate, a food substance, to be broken down, will bind together with the enzyme, are the places known as active sites of the enzyme. So the active sites are found on the enzyme. Many times people confuse where the active sites are, on the enzyme or on the substrate. But active sites are on the enzyme, just like openings, where when the substrate comes, it fits, bind, substrate, enzyme concentration. You get that? So increase in substrate concentration increases the enzyme activity up to optimum, where further increase in substrate concentration will make all the active sites of the enzyme to be occupied. When all the active sites have been occupied, then no further reaction. What if you want to increase the reaction beyond the optimum after all the active sites of the enzymes have been occupied? What should be done? Bring more enzymes. More enzymes equals to more active sites, and more active sites, then there is more provision for more substrate to bind together. Hence, the rate of the enzyme activity continues. That is substrate. That is substrate concentration and enzyme concentration. The fourth one, enzyme inhibitors. Inhibitors comes from the word inhibit, that is to prevent. What are inhibitors? These are chemical substances that prevent enzymes from functioning. There are two types: competitive inhibitors and non-competitive inhibitors. Let's start with the first one, competitive inhibitors. As earlier explained, enzymes have what we call active sites. So a competitive inhibitor competes with the substrate for the active sites of the enzyme. Remember, the active sites are found on the enzyme, and substrate need to come and fit into the active sites. But here is another substance that also wants the same active sites. Which one is this? The inhibitor. In most cases, these competitive inhibitors have the same shape as the substrate, so that when they come in, they fit. They just fit. So by the time the substrate also wants to get in, already a visitor is in. That is a competitive inhibitor. Non-competitive inhibitors, on the other hand, do not compete for the active sites. They do not compete. Rather, they just come and attach themselves on the enzyme molecule. Just attach themselves to the molecule. When they attach themselves to the molecule, it ends up changing the shape of the active sites. So when the substrate wants to fit into and bind to the active sites, the shape has changed. The rate of reaction will not be catalyzed. Those are inhibitors. The last one and the fifth one I will discuss is cofactors and coenzymes. Cofactors and coenzymes. What is the meaning of the word co? Co-pilot, co-captain, co-curricular, co-wife. They work together. So cofactors and coenzymes, they do the same thing. Both they activate the enzymes. It is so funny that enzymes activate and catalyze the rates of reactions. Then the enzymes also want to be catalyzed. And who catalyze the enzymes? Cofactors and coenzymes. The only difference is that cofactors are non-protein substances, mostly metallic ions such as molybdenum, zinc, copper, chloride, and those are the metallic ions. Those are cofactors. While coenzymes are vitamins or derived from vitamins. They are organic. But both of them, cofactors and coenzymes, they do the same thing. That is, they catalyze the enzymes. They make the enzymes work better. So those are the 5 factors affecting enzyme activity. Once again, temperature, pH, substrate concentration, and enzyme concentration. Enzyme inhibitors, which there are two, competitive and non-competitive. And lastly, which one? Cofactors and coenzymes. Cofactors and coenzymes. Thank you. We shall stop at that. Bye.